Learning outcomes. State the principle of conservation of energy. State the work energy theorem. W equal to delta K. Energy definition. The ability to do work. Quantity, scalar, unit, joule. Two types of mechanical energy, potential energy and kinetic energy. Potential energy. The energy stored in an object due to its position, state or shape. There are two types of potential energy. First, gravitational potential energy U and elastic potential energy US. Gravitational potential energy is the energy stored in an object due to its vertical position. U equal to mgh, where m is mass, g is acceleration due to gravity, and h is height. Elastic potential energy. Energy stored in elastic materials as the result of their stretching or compressing. Us equal to half kx squared, where k is spring constant or force constant. X is amount of compression or extension. Hooke's law. Now we put load by load on the spring and the graph become linear. Hooke's law states the restoring force Fs of spring is directly proportional to the amount of stretch or compression X if the limit of proportionality is not exceeded. Fs directly proportional to negative X, so we get equation Fs equal to negative Kx, where Fs is restoring force, K is spring constant, and X is displacement. Negative sign means direction of Fs is always opposite to the direction of the amount of stretch or compression X. Kinetic energy. The energy an object has because of its motion. K equal to half m squared, where m is mass of the object and v is speed of the object. Conservation of energy. For an isolated system, the total amount of energy is always constant. Summation initial energy equal to summation final energy. That means the total amount of energy always stays the same. Energy can be transferred from one form to another, but it cannot be destroyed or created. Conservation of mechanical energy. In a conservative system, the total mechanical energy is constant. If the system has no friction, then we have K initial plus U initial equal to K final plus U final. If the system has friction, then we have K initial plus U initial equal to K final plus U final plus work done by friction. Work energy theorem. Net work done on a body by all forces acting on it is equal to the change in kinetic energy of the body. W equal to K final minus K initial equal to delta K. In this picture, there is one object M is pushed by a force F and moved with initial velocity U. So, it has kinetic energy initial equal to half mu squared. After it moved for a distance s, it has final velocity v. So, it has kinetic energy final equal to half mv squared. The work done equal to K final minus K initial equal to delta K. A force doing work on an object that causes the object to speed up gives rise to an increase in object kinetic energy. Work energy theorem tells us that when work is done on an object, there is a change in energy. Okay, that's all. Thank you.